Hey guys, it's Coach Holmes,
And Coach Nelson.
and we're here to talk about plant adaptations.
That's right, kiddos. Buckle up.
It's gonna be a bumpy ride.
It's going to be bumping.
Here we go.
Okay. All right. Let's talk about thigmotropisms.
The last tropism that you didn't see in the video, we need to cover real quick.
Yeah, that's right. This is a plant's response to
Touch.
touch. And it can be positive. It can grow towards touch or...
Away from touch. That'd be a negative response.
That's right. And why would it grow away from touch?
Well, if plants get too crowded together, they aren't able to absorb as much sunlight as plants that are standing alone. So they actually do grow away from each other in order to absorb the maximum sunlight that they possibly can.
Well, plants would grow towards touch, Mr. Holmes, in case you were wondering.
I was.
You were? Okay. So that they could actually wrap around and have support. So like vines, for example, will actually grow towards touch. It's an adaptation that helps them. Okay. That ends the tropisms. Let's talk about adaptation. So let's first talk about an environment. So the environment is once again, it's natural selection. So nature is going to select adaptations that best allow plants to survive. That's a quick review. So let's look at nature here in the desert. The desert's dry, super, super hot, lots and lots of direct sunlight, which means long time to make glucose through photosynthesis. And the soil is sandy or rocky, so it doesn't hold much water. So not only is it dry, but the soil is not very suited for retaining the moisture that it does have. So in essence, plants are in danger of losing lots of water. So what kind of plant can we expect to find here? What kind of adaptations?
Well, you're not going to find any of the plants that you would normally find around here in a desert because they just simply aren't adapted enough to the desert environment. What you're going to find in a desert are plants with small, tiny little spines instead of leaves, because we all know that leaves are full of stomata and water can leave the leaf through the stomata, so they don't want that. They have spines instead of leaves, which slows the water loss. They also have really deep roots, because the deeper plants can reach into the ground, the greater the amount of water they can absorb. So they also spread out wide and reach deeper into the ground than plants that live around here. And as we all know, the cuticle is on the surface of leaves and it prevents water loss. And in fact, most plants in the desert, they have cuticle all over them. Because they want to prevent as much water loss as possible. Coach Nelson, do you happen to know what biomolecule the waxy coating on leaves are made out of?
Lipids
Wow.
or fats, yeah.
That is impressive.
Nature's water repellent.
I hope my students are going to be able to understand that and memorize that.
Coach Holmes, it's lipids.
Lipids, gotcha. Okay. Okay, so the last thing is many plants, they actually adapt to the windy environment of the desert by using it to their advantage. They have seeds that can float through the wind or even roll through the wind, such as tumbleweeds. And you always see tumbleweeds rolling through movie scenes where they're out west in the desert. That's actually an adaptation for plants to get their seeds spread out using the wind. Okay, so there's a few adaptations for desert environments. Let's look now at the opposite.
Ooh, did it just get chilly in here?
Yeah, I think so. We're looking at the tundra now, Coach Nelson. This is a place that is cold year-round. It's covered in permafrost. It's completely frozen and a thin layer across the surface.
What's frozen?
The ground is.
Oh, the ground?
The ground, believe it or not, it's cold enough to freeze. And because it's all frozen, that means there isn't really any water available for the plants to use. So technically, it's dry.
Wow, interesting.
Coach Nelson, you want to tell us how plants adapt to that cold and tundra environment?
It would be my pleasure. All right, kiddos, listen up. Plants, one of the adaptations that allow plants to thrive is that they're small and they grow very close to the ground, and that's to keep them out of the really cold parts of the area. Believe it or not, it's actually colder closer to the ground than it is way up high.
Right.
So
Okay.
plants that are close to the ground tend to thrive.
Okay.
Also, plants like grasses have really long roots. So once again, if you recall back to the desert, plants with long roots tend to thrive in drier areas. And so you'll see lots of grasses. Also, the plants that do grow in this area tend to be darker in color. Why, may you say? It's to maximize the absorption of sunlight. The more sunlight you can absorb as a plant, the more likely you are to be able to perform photosynthesis. And that's necessary for all plants since they're autotrophs.
Absolutely.
What does the autotrophs mean again?
Well, if I'm remembering correctly, I believe it's where they make their own energy somehow.
Ding, ding,
Usually
ding.
through photosynthesis.
Boom, boom. All right, and then finally, another adaptation is that plants tend to grow in clumps.
How does that help them survive in the tundra?
Well, just imagine you and all your friends are really cold. Y'all may huddle up together and maybe share a blanket.
All the time.
All the time.
All the time.
So plants do the same thing. By huddling up, they protect the other plants from the colder weather. So it's kind of an adaptation that keeps them a little bit warmer when the really cold parts of the tundra.
That's really nice of them.
Yeah. All right. So that pretty much sums it up. We just wanted to point out that in each area, depending on what nature has in store, you'll find different plants with different types of adaptations. The roots can adapt, stems can adapt, leaves can adapt, and the way that they produce their seeds can all be adapted to that particular environment to allow them to thrive.
Well said.
Boom.
All right, this is Coach Holmes
Coach Nelson,
signing off.
we out.